All right, so today we are going to review something that you learned in Algebra 1 that I'm sure is very near and dear to your heart, and that is the quadratic formula. You do need to know the quadratic formula. It is not given to you, so if you are looking at these notes every single time, you are doing yourself a disservice. You need to know and memorize the quadratic formula because it's going to come up all throughout this year. So the way that we read the quadratic formula, and it helps us find solutions of any quadratic equation. So I stressed in the completing the square notes that completing the square can be done for any quadratic as well. Now sometimes they come out as fractions and it gets a little messy with radicals and fractions and imaginaries, but you can use completing the square for any quadratic, and you can also use the quadratic formula for any quadratic. So it's opposite of b. Don't say negative b, because if the value of b is negative, this opposite needs to turn it positive. So it's opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So notice the placement of the square root. It's over all of this over here. It is not over the denominator. So just pay attention to the pieces that you have. So the first learning goal for today is to be able to use the quadratic formula to solve a quadratic equation. So that's what we have in example 1. 3 different sets of using the quadratic formula in order to solve a quadratic equation. So, in order to use the quadratic formula, the a, b, and c are based upon having it in standard form. Ax squared plus bx plus c equals 0. So you have to make sure it's in the right form first before you start plugging in numbers. So this one over here, I need to subtract the 35 first, so I'll rewrite it 3x squared plus 8x minus 35 is equal to 0. So a is always my coefficient of the squared term, b is the plain x term, and c is my constant term. So a is 3, b is 8, c is negative 35. The rest is, can you plug it in and can you simplify? Please do not rely on your calculator to plug all of this in, because when things don't come out evenly, that calculator isn't helping you. Because if you have a radical, you have to simplify it. So I'm going to show you exactly how I want you to work these. So opposite of b in this case would be opposite of 8 plus or minus square root b squared. So 8 squared minus 4 times a, which is 3, times c, which is negative 35. Whole thing divided by 2 times a. So when I go to simplify this, I need to simplify it in pieces, because if it all comes out perfectly even, then yeah, your calculator can probably help you out. But when it doesn't, you're going to be stuck and not know what to do. I would like for you to simplify what's in here first. So 8 squared is 64. Then negative 4 times 3 is negative 12. And then I've got to multiply that still times a negative 35. So that gives me 64 plus, and then this is 420. So when I take the negative 12 times the negative 35, oops, I said 400 and I wrote 100, gives me 420. So I've got negative 8 plus or minus square root 64 plus 420 over 2 times 3, which is 6. So I'm going to simplify what's in the square root. Order of operations tells us we have to do that because square roots are like parentheses. You have to do what's inside first. So that gives me the square root of 484 over 6. Now, you should always check to see if this radical comes out evenly first. So just press into your calculator square root of 484. Because if it comes out evenly, that makes our life a lot easier. If it doesn't, we're going to have to do some radical simplification. Hopefully, when you punch that in, you found that it did come out evenly. The square root of 484 is 22. So remember that this plus or minus right here separates it into two separate problems. Write them out so you don't forget. It's negative 8 plus 22 divided by 6. And then on the bottom side, negative 8 minus 22 divided by 6. It's two separate problems. So negative 8 plus the 22 gives me 14. 14 divided by 6 does not come out evenly, but it does reduce because they're both divisible by 2. So that first one gives me x equals 7 over 3 as one of my answers. This one over here, negative 8 minus 22 is negative 30. Divided by 6 is negative 5. So that one did come out evenly. So x equals 7/3 and x equals negative 5 are our two solutions. Again, notice how I simplified it. I simplified the squared and this multiplication first before I added, and then I did that before I dealt with any of the other items there. All right, let's try one more. Again, I need to get it all equal to 0 before I can start plugging things in. So I need to move together my like terms. So I'm going to add 5 to combine over here. I need to get rid of this 12x also by subtracting. When you list it, make sure you list it in standard form so you don't mix up your a, b, and c. So standard form, this comes first, these squared terms, so 2x squared. Then my plain x term, so minus 12x, and then my constant, which is plus 18. So now that I have it equal to 0, I can identify my a, my b, and my c. So a is in front of the squared term here, so it's 2. B is in front of the plain x term, so negative 12. And c is my constant, which is positive 18. So now plug it in. And I'm just going to kind of draw a line here to separate that side from this side so the problems don't run together. So opposite of negative 12 is 12, plus or minus square root negative 12 squared minus 4 times a times c. Whole thing divided by 2a. Again, when I simplify, I'm going to simplify in here first. So I leave that out front. Negative 12 squared is positive 144. Then negative 4 times 2 is negative 8. Negative 8 times 18 is negative 144. And then on the bottom, 2 times 2 is 4. 144 minus 144 is 0. And the square root of 0 is 0. So I end up with 12 plus or minus 0 over 4. Now, yes, this is two separate problems. However, you get the same thing when you add 0 as when you subtract 0. So this ends up being a double root, meaning that the solution repeats itself. 12 plus 0 is 12, divided by 4 is 3. So the solution, and there's just one of them this time, is x equals 3. All right. I would like for you to try C on your own. So pause it, work it, and see if you can come up with the correct solution. So first thing you should have done is move this stuff so that it's together. So I added the 2x, subtracted the 3. So negative 2x squared plus 2x minus 3 equals 0. So that means A is negative 2, B is positive 2, C is negative 3. Now I always get people who ask, what if I moved it to the other side? Is that okay? Yes, but double check to make sure that your A, B, and C are all opposites of mine. So if you did it that way, your A would be 2, your B would be negative 2, and your C would be positive 3. All right, so now I'm going to plug in. So opposite of b, so -2 plus or minus square root b squared, so 2 squared minus 4 times a times c. Here was my a, here was my c. And that whole thing divided by 2 times a. So inside the square roots is what would come next. So 2 squared is 4. -4 times -2 is +8. +8 times -3 is -24. And on the bottom, 2 times -2 is -4. So when I simplify, this is going to give me -2 plus or minus radical -20 over -4. So this is the first time that our square root hasn't come out evenly. And not only does it not come out evenly, it also is a negative, which should be telling you that there's going to be an I in the answer. Now I know it's going to have an I in it, but I also need to break down the 20. 20 is 4 times 5. So its biggest perfect square is 4. So this is really going to be 2 radical 5, and then because it was negative, that means I'm going to need an I to go in it. So that's -2 plus or minus 2I radical 5 over -4. Now, because you have two negatives here, you can reduce the negatives, but you can also, because all of these, and we had one of these on the practice I worksheets, these are all divisible by 2, so we can reduce that as well. So divide them by 2 and cancel both the negatives if you want. If you want to leave them, you're more than welcome to. So if you want to leave it -1 plus or minus I radical 5 over -2, that's fine. If you had your 1 and your 2 positive, that's also okay. But again, what I've done here is taken all of these coefficients, which were divisible by 2, and reduced them. So there is my answer right there. All right, believe it or not, that is the hard part. Something that you did exactly over and over again in Algebra 1. The only thing you didn't do in Algebra 1 was have ones that came out with i's. But simplifying i's, of course, is not new in this section. So now, the second thing we need to be able to do is to find what's called the discriminant of the quadratic equation. And up at the top of the notes here, I've got it defined. The discriminant is just the b squared minus 4ac part. That b squared minus 4ac is going to tell us the number of solutions and what type of solutions. So the rule is, right down here, if the discriminant is positive, there's 2 real solutions. If the discriminant is 0, so b squared minus 4ac gives you 0, there's just 1 real solution, which we call a double root. And then if the discriminant is negative, then that means there's 2 solutions that have i's in them. They're imaginary or complex solutions. Now, the location of the discriminant in the quadratic formula is under the square root. So when you're asked to find the discriminant, you're just finding the part that would be underneath the square root. You don't actually need the square root symbol. So I just need b squared minus 4ac. So this lovely one in example 2a is already in standard form for me. So b squared, 6 squared minus 4 times a, which is 9, times c, which is 1. So I get 36 minus 36, which is 0. So if my discriminant is 0, I go to my chart. 0 means there's 1 real solution that is a double root. So it says find the discriminant, so the discriminant 0, this is one of our answers, and give the number and type of solutions. So there's 1 real solution. So 1 is the number, real is the type. So 1 real solution. Now, if I make a little change to c here, notice most of the front's the same. B squared, still 6 squared, minus 4 times 9 times -4. So I've got 36. Negative 4 times 9 is negative 36. Times 4 again is 144. So I'm going to add that. Then 36 plus 144 is 180. So I look at my chart. Positive means that there are two real solutions. So 180 is the discriminant. And two real solutions is the number. All right, last one of this type, example 2C, I'd like for you to find the discriminant and determine how many solutions there are. Then unpause to come back and check. This is my A, this is my B, this is my C, so B squared, so 3 squared minus 4 times A, which is 5, times C, which is 1. So 9 minus 20 times 1, so negative 20, which is negative 11. And we know that if the discriminant is negative, go back up to your chart, hopefully you said that that means that there's two imaginary solutions. All right. This next part is kind of an application, bringing it together and making sure you understand what we are doing. When we are solving quadratic equations, we are finding x-intercepts or zeros. So we can do that many different ways. We can do that by graphing, we can do that by factoring, we can do that by taking square roots. Now with the quadratic formula. So remember that the solutions are x-intercepts. So our discriminant tells us if there's two real solutions, which would mean if there are two real solutions, that means there should be two x-intercepts. If there's one real solution, there should be one x-intercept. And if there's no real solution, that means that there should be no x-intercepts, which means it doesn't cross the axis at all. So what this question is asking us to do is it says from the graph of an unknown quadratic, tell whether the discriminant is positive, negative, or 0. So you have to use this information that I just kind of wrote down that you should know. If you look at this graph, this parabola does not cross my x-axis, which means there are no x-intercepts. So if there are no x-intercepts, that means that there are no real zeros. So if there are no real zeros, your discriminant chart, no real solutions, means that that had to have a negative discriminant, because it means that those solutions must be imaginary, because I can't see them. On the second one here, I do have two very visible x-intercepts right there. So that means if there are two visible x-intercepts, that means that there are two zeros, two solutions that are real. So I go back and look. Two real solutions means that the discriminant was positive, because here are your two real solutions. Last one, again, solutions are x-intercepts. So here's an x-intercept right there. That, and there's only one left that's different, but with one x-intercept, that means there's one real solution. So that means that the discriminant here would have to be 0, because that's the way that we get one real solution. So that means my discriminant was 0. My reasoning is because there is just one real solution. So hopefully that makes sense. That is it for this lesson.